All right, before we move on to example 5, let's step back and think about what we learned from those last few examples. So the last two examples involved a horizontal shift, and we found that if we make a change to the input of the function, it results in a horizontal shift, right? So a horizontal shift involves a change to the input to the function. And it's sometimes called an inside change, right? So if you think of the input as going inside of the function, that's why it's called an inside change. So if h is a positive constant, right? So h is greater than 0. We found that when we subtract something from the input to the function, then it shifts it to the right in the positive direction. So this results in a shift to the right. Okay, and that seems a little counterintuitive, but if you think about it, what we're doing is subtracting a positive constant from x before we feed it into the function. So it's going to take more input to achieve the same amount of output, and that's why it shifts it to the right in the positive direction, because it's gonna increase the amount of x we need in order to get the same amount of function out. Okay, and on the flip side, if we add something to x before we feed it into the function, now we've increased x, it doesn't take as much. It takes less x to achieve the same amount of output. So we ended up with a shift to the left, right? So a shift to the left is in the negative direction. Now that seems a little counterintuitive until you think about the fact that we're taking x and adding something to it before we feed it into the function. So the amount of x it takes to achieve the same amount of output is less, right? Because we're adding something to it before we go put it in the function. All right, so the vertical shifts are a little more straightforward. They're a little more intuitive because we're just adding something to the output, right? So a vertical shift involves a change to the output to the function. So we either added or subtracted something from the output. And so this is sometimes called an outside change. Outside change, right? Because we're changing the output of the function. So it's already been fed into the function, and we're just going to change the output. And if we take the output of a function and we add a positive constant to it, so we're assuming k is greater than 0 here, it's gonna shift the graph up, right, by k units. All right, and if we take the output of a function and then subtract something from the output, it's going to shift it down. Okay, so shifting up and down, that's a vertical shift. All right, let's take a look now at example 5. In example 5, all we know about g of x is that it passes through the point 3, negative 4, and we want to figure out, okay, what point has to be on the graph of these new functions. Okay, so the first one, you can see it's an outside change, right? We're taking g of x and then adding 6 to it. So we know how g of x works, right? G of x, okay, I'm just going to model it as like I did up above. So I'm taking the function g, and it takes some input, which I'm representing with the parentheses, right? And the way it works, the only thing we know about g of x is if we put 3 in, then what we get out is a negative 4. Okay, then we're taking the output of that function, and we're going to add 6 to it. Okay, so we end up with negative 4 plus 6, which is 2. All right, so for this new function, g of x plus 6, our input is 3, and our new output is 2. So the point that has to be on the graph of g of x plus 6, right? G of x plus 6 is 3, 2. And you can see that we shifted it up by 6, right? We took the output and shifted it up by 6. All right. All right, let's take a look at the next example. All right, so now we have an inside change. So g of x still works the way, we're told it works, right? So if this is our g function, and we know that if we put a 3 in, we're going to get a -4 out. All right, that's the only thing we know about g of x. But now we're modifying the input, right? So we take whatever the input is and we subtract 2 from it. Okay? So we want the output to be 3 because that's the only input value that we know about for g of x. So what x value will give you a 3 after you subtract 2 from it? Well, that has to be 5, right? If I take 5 minus 2, I get 3. All right, and that's the input value I want because that's the only thing I know about g of x is for that input value. And I'm going to get -4, right? So the point that I know, right, for this new function, g of x minus 2, g of the quantity x minus 2, so x minus 2 is the input to the function, right? My new input is 5, and it gives me the output of -4. Okay, so the point that's on the graph of this new function is 5, -4. So you can see we've basically we've shifted the x value to the right by 2, right? We've added 2 to the x value to get the new point. So you can see that it's a shift to the right. It's a shift in the positive direction. Okay. All right. All right. So now this next one, we've got a couple of different things going on. We've got an input change and an output change. But what we know is that, let me make this a little bigger. We know that g works, it works the same as what we're told, right? We put 3 in and we get a -4 out, all right? We can start with that. Now we're modifying the input, right? So I'm taking the input and adding 1 to it. And I'm going to take the output and I'm going to subtract 2 from it. All right, so let's take a look at what input it will take, right? What x value will give us 3 after we add 1 to it. All right, so this is going to have to be a 2, right? So if we have an input of 2, then 2 plus 1 is 3, and that's the input that I want for g of x because that's the value I know. We feed that 3 into g of x, we get -4, and then we're going to subtract 2 from it. So we're going to end up with a -6. Okay? So what that's telling me is now that the new point that I know on this new function is 2, -6, right? So 2, -6 has to be on this new function. And you can see that, this is shifting it to the left, right? This is a leftward shift. This +1, x plus 1 shifts it to the left, which you can see. I took this and shifted it to took the original input and shifted it to the left by 1. It gives me 2. And it shifts the output then, this goes down by a -2, right? And you can see that the original point is shifted down by 2. All right, so there you go. Now you might not have to draw these little diagrams every time you do one of these problems, but I want to make sure you understand why you're getting the shifts that you are.